So why don't I do this? I start with an overview of what we're going to talk about. And then we will actually talk about, and again, everybody is welcome to participate, but I have something stronger than just asking you to participate. Real quick, checking if there is anything urgent. No, it's all related to this. Okay, great. So here's what I have. First of all, there was an interesting article, mostly interesting, I think, because of the nice picture there, but also interesting because of what's inside. And then I did investigate. I went inside, found that article, so it wasn't easy. Meanwhile, the process of Quiskit advocate. That's a community of people who all want to be connected to Quiskit somehow. And to me, it's just a push, just like that webinar is a push to be organized and do new steps every week. So that is the same with this Quiskit advocate. So I'll talk about that. I'll talk about what's new and what my plan for that is. Okay, let us start. First of all, the research student in Poland did something interesting for quantum computing. So all these links are part of the story. First of all, that link comes here from physics.org. So that's good enough. And if I wanted to spare you guys of these advertisements, then I would have to pay the money, so I didn't. And maybe can eliminate this, but then other ads will come in. So that's a funny group of students. What is funny, of course, is that they got themselves those cats somehow. I wonder if we all can get these cats, especially when we become experts and we will be able to turn this cat upside down. I think what they are illustrating is the superposition of the quantum bit, qubit. It can be 1 or 0, or anything between. That's what they're showing. But what they really have done is they have practically proven using quantum memory that they can do Fourier transform using quantum memory. Now, what is special about this is that Fourier transform is part of many algorithms. One of them is Peter Shor. He does use fast Fourier transform there, and Peter Shor, his algorithm finds the prime dividers. So what is this fast Fourier transform? That allows you to squeeze the distribution wave. So this cat represents the state of the qubit, which, as we said, it can have many states at once. And that's why the whole story is about the cat, because did Schrodinger love cats or no? How could he invent an example where the cat would potentially be dead? That's a terrible thing to think about for those people who are into cats. And they say no, actual cats were hurt. Nice. But back, we're talking about this cat that illustrated the unusual fact about the qubit. And then, of course, he was not formulating it as qubits. He was talking about electron or photon or any other particle which could have a certain state, but all the time that you don't measure it, it doesn't tell you what state it is. And the philosophical question, is it in any state at all or no? So we can go as deep as we want into this philosophy, but practically they say that if you give them quantum memory, then they will be doing a fast Fourier transform, moreover fractional fast Fourier transform, and that will help them with new algorithm. So how does it help? How does it help Peter Shor with his algorithm? In short, it does this. It says there are lots of numbers in the world. And in order to find the right one, I would have to try every one of them. That's exactly what is not possible. Instead, he says, I will squeeze them so that the space of the right ones will be much bigger and the space of the wrong ones will be much smaller. Then all I have to do is to find those numbers that fall into the space of the hopefully the right ones and check them out. Maybe you have 4 or 5 numbers. Now, practically, as we remember, it's not there as yet, and I hope, well, we're doing those webinars, eventually we'll celebrate that it's there. But practically, all they could do is to prove that 15 is 5 times 3, and that you could do in your brain, or you can do it on a computer. Practically not yet, but theoretically, yes, they will be able to use this transform and create more algorithms. So last time I showed you how to create new algorithms. Let's go back. Here, there was a nice lecture on how to create new algorithms. I think it was right here, there. How to create quantum computing algorithms. Not an easy topic, admittedly, but that gives you tremendous hope, because up until now, we would always think that, okay, we use those algorithms that are already there, but the new ones, that's out of our reach. So that, guys, shows you a framework how you could create new algorithms. That's encouraging. And then those Polish guys, the students, they show you how you can use the fast Fourier transform, and that is helpful in your algorithms. That's it. Let me check on the chat. Did anybody say anything? No, not yet. And let me check who is with us here. Okay, there are a few more people here. There is Aisha, and I will allow everybody to talk, including the new arrivals. Here we are. Now, let's go a bit more practical. So I got a letter from IBM, from Quiskit, and that is because, oh, I didn't finish this investigation, didn't show you that if you go here, because I didn't believe them, the article itself here, it says that that appeared in the here physical review letters. So who believes that? So I went and investigated that, and I found the physical review letters as a publication. But even there, it was not on top. It was published in June 12, 2023. So that was the latest news, but I had to find it. So I found it, and that's it. But again, I didn't trust that it will stay there. And so right here is an article itself. So if you click here, okay, I saved it as a PDF right here, and you can go to the source, because every time you don't go to the source, we don't quite believe that, right? But it's interesting. Received March 7, accepted May 12, published June 12. That's amazingly fast, right? I didn't even know that we're there. We are in a fast lane. Okay, now you can do a complete investigation and go deeper into whatever you want. All right, here, practical. So if you apply and you want to become a Quiskit advocate, which is today a community of 4,000 people or about that, then you will get a voucher. When you get the voucher, you will have a chance to take the exam for free with the voucher, which is nice. I thought, to stimulate myself, I'll do this. So it's not an easy thing, obviously, to manage those vouchers, and they couldn't generate this. Okay, jokes aside, they couldn't generate it. They sent a letter which says that it will come. And I already hope that, okay, I'm off the hook and don't have to take the exam. But no, it came back and it says the original deadline to pass the certification was July 15, but now we're going to extend it. And I don't even know when, So guys, stay tuned, right? That would not be such a great news. But the great news is that they give you those links, these two links. I'm not clicking on them because I'll show you them where they really are. And these are useful links, well organized. I must say they're well organized to help you prepare. All right, well, I decided let's do it as a group. Here's my plan. First of all, I collected all of the materials there in the Quiskit exam preparation repo. Let's open. That's the repo. Now, it's not that big, but that is where I plan to collect everything. With full instructions, you will be able to come in, clone that repository because it's open, and the link to it is right here. So everything is ready for you. And we'll go through that through the start. Then I plan to continue moving here every week so that we're learning together. We're learning the latest and the greatest, even though that doesn't really change. All these exam preparation tips, they're 2 years old, that doesn't change, but we will be at least using the latest version. Okay, so I'm giving you a plan, but I'm giving you a bit more. Well, so if I'm lucky and I do get this particular voucher, then the exam is free for me, but it's not fair, guys, because it's not free for you. So first of all, you probably missed the application deadline because the application is only through June. And that is just the fallout of my application. But you will be able to take the exam. You will not be able to become a Quiskit advocate this time. Now, you may have mixed feelings about becoming this advocate. It's a corporate initiative. It's IBM pushing the world into quantum computing. So why should you help the corporation? But it's a fun group of people. That's what I noticed. They are all, I'm not sure if I even have it here, but let's do the Slack. Let's open the Slack. If it opens for me here, then I might show you the community, but that is on the condition that I'm logged in. No, I will again, because now that I'm on the Mac, it's a different computer, so it doesn't matter. But the guys, they are fun. So that could be the reason, and you might do it the next year, but I also prepared an offer. So my offer is to equalize our positions if you pass. No, let's not make it bold. It's not if you pass the exam. I will pay for your voucher. Really not for the voucher, but it's properly said I will refund the exam cost. And that I'm doing just so that it's more exciting, right? Now, who thinks that it is exciting? I'm going to the chat. Who thinks that it is an offer worth considering? Okay. So say +1. Oh, yes. Something like that. And it's kind of splits it between us. So if you don't pass, then you lose. But if you do pass, you win. Okay. I don't see you guys being very excited, but let's assume I was there. At least you will be able to, you know, pass for free. Okay. Now let's go. Let's go to this report. Let's close what we don't need. And the two things that I want to show you today are those links. So first of all, there is the Quiskit syllabus and then the study guide. I think it's either here or there. Let's see. Okay, no, it's in the wrong order. So let's do it this way. Let's right away change the order. Okay, let's put it here so that the first thing first. And now let us commit those changes. Okay, so first is the study guide, and secondly, it's the syllabus. So study guide, it's fun right here because you have to figure out how it works. It says it is a bunch of slides, and it is, but you need to realize that don't click on this link because you'll get back to the same place. Rather, go click here to make it large, and then keep going here to see the next slide. That is the story. So again, it's pretty good compendium materials, and it's talking about the test itself. Itself has 60 questions. You need to answer correctly 44 of them. This test is now live. You can take it anytime. All right, and let's go. Let's look at what it's talking about. So first of all, we noticed that it's 21, but that's good enough because it came from IBM yesterday, and that's the guy, one of the fun guys who is an advocate himself, and that particular advocate does also work at IBM and also wrote a book. So all the honor goes to him, but you can do this. You see, you can hit the key, right, left, up, down. Yeah, even right, left, and up, down works. And it's talking about, yes, we're the first certification, but then it talks more about how to prepare. So you see those arrows, they're nice. They are really pointing out the right thing. So he goes through this, what is on the exam, and he also explains how that works. And then I think there is a place where you can click and it will be a playground. I don't see it here, but oh, here, there you are. Let's go there. That's the playground that shows you the famous Bloch sphere, and it's live. Isn't that nice? Now, of course, that represents different probabilities of finding your qubit in different places, and that explains the formulas. I can go back, and we're right here, and now we begin to appreciate what kind of material. That's a good material. So just learn, right? The knowledge is abundant. You just have to do that. Okay, so he talks about that, but then he goes through the Quiskit textbook, and I feel awkward. I think the Quiskit is not the greatest possible name. I agree with my wife on that, but it's like Kit Kat, but maybe that's what they meant. In any case, he goes then through the tutorial and points, look here, and then look here, and then look here. And then I want to advance to the place where you will see example questions. So here you will have the study areas. That's what you need to know. And later on, there will be sample questions. So let's go. Let's come to the sample right here, 20 sample questions. And it's each certificate exam question is one of these objectives. So let's explain even that. I think that's a good explanation. All that's missing is your brain that will do this. Now, of course, you can delegate that to ChatGPT. Less time than one of the talking heads on IBM tried that. It didn't quite pass, but of course, now it probably can, right? But no, they don't get certificates for that. And even though you can use ChatGPT to write any kind of code for you, that's a whole philosophy today. Will ChatGPT be my enemy or will it be my friend? By the way, my personal opinion is that a friend, and I see this every day. Every day there's some interesting new thing comes up that it is a friend, and no, the jobs are not taken away, that they shift. So some obvious things that he can do, he should do, and other things, it's up to you. So I think it's a great cooperation, but lots of things are happening in the world. Okay, so let's keep going through the questions, and some people may continue to have the next webinar, which is after this one, talking about ChatGPT. I'm not surprised because these are the two most interesting, most complex, most hot topics right now: quantum computing and AI, right? But right now, the world doesn't appreciate how important that is. So we have only, let's see, how many people here? We have 6 people here. Yep. And Alba, I'm allowing you to talk also. All right, let's continue. That's our plan. Let's look at what, let's try to do one question, okay? Simple question number 1. Which statement will create a quantum circuit with 4 quantum bits and 4 classical bits? All right, everybody is trying their hand on that. I'm opening the chat. And I'm saying question 1. Okay. Okay, guys, that's your turn. Can you answer? No, I don't see you guys answering, so we'll have to work through. First of all, I'll take a bold guess. I will think that it is A. It might be B also. Maybe by default, the classical bits number is equal to quantum bits. So for those people who need a refresher, I'll explain that before you do any kind of computation, you build yourself a quantum circuits. So every time you build a new computer, virtual computer, and in that virtual computer, you ask for a certain number of quantum bits and a certain number of classical bits. Now, there are simulators, and for small, up until I think about 30 quantum bits, the simulator works. Beyond that, it's harder. And the maximum number you can have today, who remembers the maximum number? I think it is about 500, 433, I think. That's the max. But once you go beyond, yes, build a circuit. Okay, thank you, Lawrence. Let's click on that, and everybody says, yes, build a circuit. So does it have an answer here? Quantum circuit 3. So it will be 3 qubits. What about classical bits? And that is because after you build and maybe compute something, you need to read out the results. And these results you will be reading into classical bits. So that's why you need classical bits, but that's just a convention of the library. They could have done it 3-3, or they could have done it 3, assuming that another 3 will appear. So thank you, Lawrence. Let's go back and let's see what this guy will say, right? All right, that's the answer. A circuit is a list of instructions how to build your registers. And if you look at this golden chandelier, which is the computer, and most of these are wires connecting the pretty small qubits. So what does he say for the answer? A list of register object. He goes pretty deep into what is that's Python. Remember, what is the structure of the object? For example, he talks about quantum circuit of quantum register. That's what you don't see because you just say quantum circuit. And then how many quantum register and how many classical register. So you can put anything here, but we wonder what is the final answer. It says that is a quantum circuit with 4 qubits, and that is a quantum circuit with 4 qubits and 3 classical bits. So what's the answer? Okay, that's the arrow pointing there. He didn't say. Well, how about this? That was only, oh, he did say A. Okay, 4-4. Okay, but if you could copy paste that part, you could ask ChatGPT, and of course it should answer that. Or you could type, and very soon you'll be able to give it pictures. That was question 1, and we answered it successfully. He goes through many, many more questions. For example, here's question 3. That one we will only read. It says Bloch sphere. In other words, that is a presentation essentially of imaginary numbers. That is what the picture is. And then the question is given this code fragment. What is the probability that a measurement would result in qubit? That's a notation how to represent your qubit. And it will be greater than that number, I guess. So not going into that, but he goes into that. He shows you that sphere and what the elements mean, and that's how he calculates it. And the result is C. Well, that is a harder question. And I'm sure that if you do this kind of mental math and gymnastics, then your brain will function better tomorrow. Okay, that is it. That's what I wanted to show you as far as the first part. Now, there is the second part. So we said that it is all in the repository right here. So we open the repository and I went first to this thing, the study guide by Mr. Weaver, I believe. Now the Quiskit developer syllabus, that is here. And again, that's by him, same James Weaver, but that's a long thing. I tried to log in. Let's try to do this. I don't see a big need for that, but you can get a free account. Let's see, here you are. And what? It doesn't remember my password? No, it doesn't, okay. But I honestly, I looked in on another computer and I didn't see anything more special than here. So we already see this. And then you can run through all of the tutorials, and the tutorials now work. That is the difference between what was and what is now. They fixed them. So if you go into the tutorials, they all allow to run there. And of course, I will not recommend to run there because tomorrow if they break, what happens? No, you need your own. And that is what my repository will have. That will have the code and you will be able to run them a complete instruction on exactly how to do it. So I already have one repository. One repository is there. Font scale. Let's find it. Quantum Computing Labs, it's there, and it has a lot of labs, but 3 months ago, 5 months ago, that's too long ago. You need to refresh it. So I'm creating a new repository that will not be just a set of dry instructions. That's what it is. That's what it says. You need to do this, and then you need to do that. But it will be more in the style of I'm preparing and helping you. Okay, that is all that I have for today. So the offer stands right here. I promised that we will look at the article with the funny cats, and we will also look at what is latest. Now, what you can do is do me a favor. So that's the repository, right? You go to this repository, you find it here. Right now, I just created it, so there is nobody here. Well, I would recommend you fork that repository or you watch it in some other way. You click right here and you choose your account and you'll get a copy. That way you'll be notified when anything is interesting there. You will be able to do something. You will be able to then maybe even change something and commit them to your branch, to your forked repository, and even make a pull request. Say, Mark, look, I've changed this thing here. That's why I did it. And they will appear here. Okay. That is the plan. You tell me how you like it or you don't. But in the absence of nay, I will say it's a yay and I will continue. All right, let me stop screen share. Okay, and I hope to see you next week, right? If everything is going fine, we will meet again and we will be doing some progress. Okay, guys, and you maybe will share. I will go over what I have done. I'll show you what new things are there and what you can use for your progress. So I hope you're doing good. And until next week, I'm saying goodbye for now. Yes, see me in AI session and we'll be talking about there. And thank you guys, and have a great weekend. You too. Oh, by the way, the important thing is that they did schedule. You know, there's one guy, one company that I'm teaching this quantum computing for, and one of you knows about that very well. So, okay, they scheduled the new session. That's sometime in October, and we change a little bit. We changed the emphasis. We changed the way we how. I'll show you what's the new name. Quantum computing and preparing today for a quantum computing tomorrow is the new title. It is essentially the same outline. So if you took that course, you're already there, but we'll be talking more along these lines because I believe that any technical company worth its salt should have a plan for quantum computing. Okay, we're not going into why and on all of that, but should. And that is the new way, the new positioning of this course, that Honestly, it's not practical yet, but it's so important that you should prepare now. That is the story, and that is the last thing I will tell you. Oh, and I was not sharing the screen at this point. Too bad. Share screen. Okay, now you see quantum computing. We'll be teaching it in October, and preparing today for quantum computing tomorrow will be the outline. All right, so thank you very much. I enjoyed it. Wishing you all the best, and goodbye for now.